Now we're going to learn how to solve exponential and logarithmic equations. So some of these can get involved. I'm going to teach you really one way how to do most of these, and there's going to be an exception that we'll get to. So first, we're going to talk about an equivalence property for exponential expressions. So this is something that we've already looked at, but now we're just going to formally write it down. So this really isn't anything new. So equivalence property for exponential expressions. So I'm just going to leave it at exponential equivalence property for now. But this is for exponentials. And it says if you have b to the x power equal b to the y power, so the bases are the same, then this implies that x is equal to y. So you set, if you have the base, if the bases are the same, then you set the exponents equal to each other. That's what that's saying. So if you had, just for example, we've seen along the lines of 10 to the y is equal to 10 cubed. So that implies y is equal to 3. That's just example 1, we'll say. Example 2, we've had something like this. 5 to the x is equal to 25. That doesn't do a lot for us here, but if we rewrite it as 5 to the x is equal to 5 squared, well, that implies that x is equal to 2. All right, so you could have told me off your head that this was 2, but we're going to get into some examples here later where this equivalence property is going to be essential. And in fact, that's going to be the first example we're going to look at. So we'll call this example 1. And let's just say solve. And here's part A. So we have 3 raised to the 2x minus 6 power is equal to 81. Okay, so through all these examples, we're combining everything that we've learned from the previous sections. And here we're going to start with using this equivalence property that I just showed you. So first, this is the easiest way to work one of these problems is by making the bases the same. So always check that first. If you can make the bases the same, then it makes the whole problem a lot easier. Now, realistically, you're only going to see 1 or 2 of these maybe on a test. All right, so, but it's an important property to know. So here, on the left, my base is 3, and on the right, I have it 81. So when you get one of these problems, ask yourself, is there a way I can rewrite the bases here so that way I make them the same? And in this case, we can do that. It's 3 raised to the 2x minus 6 is equal to 3 to the 4th power. So, and that is great news because since we made our bases the same, that means we can set our exponents equal to each other. Think of this step right here the same as this one right here. We set, since the bases are the same, we set their exponents equal to each other now. So we get 2x minus 6 is equal to 4. And then from here, it's just simple algebra. Add 6, divide by 2. So x is equal to 5. What that's saying is, if I take this x value of 5, plug it back into this original function up here for x, then these two things will equal each other. And so there you go. That one is finished. You try this one by yourself. So we get 4 raised to the 2x minus 3 is equal to 64. All right, pause it. And I'm going to just go ahead and work it. All right, so I'm trying to solve this for x. And first thing I want to check is, can I make the bases the same? Because that makes my life so much easier. So here's a 4 and 64. So I can rewrite this 64 with a base of 4. 2 raised to the 2x minus 3 is equal to 4 cubed. Now that my bases are the same, that means I can just set the exponents equals to each other. And here it's just algebra again. Add 3, divide by 2. That's saying if I plug 3 in here for x, these two things will equal each other. All right. What about this one? Part C. 7 to the x power is equal to 60. So can I make the bases the same here? That's the first thing I always check. Well, is there a way to rewrite this 60 so that way it has a base of 70? A base of 7. No, there isn't. So now we have to not necessarily come up with a new way, but we have to think of a new way to work or rewrite this problem. All right, and there's two different ways that you can go about doing this, and both are useful in their own right. So the first way I want to do it is, and in fact we're just going to do it one way. Later on I'm going to show you in another example how to work something two different ways. But here, what form are we in? That's the second thing you need to start thinking about. First is, can I make the bases the same? So those were the previous examples we did. So here we can't make the bases the same. So next I need to look at what form am I in, or what form can I make it by rearranging some terms. So here you notice that this is a form we worked with before. This is exponential form. It's b to the x is equal to y. All right? So if I'm in exponential form, how did we solve earlier those problems? We converted to logarithmic form. All right? And also note that our variables in the exponent. To get variables out of exponents, we always use logarithmic form. So that's what we're going to do here. So just as a refresher on how to convert from exponential to log, let's say I'm struggling, it's been a while, so I know there's a log in here, and I know there's an equal sign somewhere. Alright, so it's log base of something is equal to something. Log base. So my base up here is 7, so that's my 7 here. And I know when I'm going to logarithmic form that it's to get exponents by themselves. So I know my exponent goes over here. My exponent is x. And then what's left over by default is that 60, so that goes there. And would you look at that? That would be our answer. Okay. So there is a second way to do this, and I do want to show you now that I've thought it over for a minute. This is option 1, and this is the fastest way, and I'm okay with you doing this. Option 2, which there will be cases where this will be easier to do. So let's just start over. 7x to the 60 power. 7 to the x power is equal to 60. All right, so we have to go back to the roots of algebra and ask ourselves, or not ask ourselves, but ask ourselves, what if we do something to one side of the equation, then we have to do it to the other side. So if I do something on this left side, the 7 to the x power, I have to do it over here also. And so that was typically when we were adding numbers and multiplying numbers. As long as we did them on both sides, then we're still fine. The same thing is going to happen here, except we can use natural logs or logs. So what I'm going to do is I'm going to say the natural log of both sides. Natural log of 7 to the x power is equal to the natural log of 60. So as long as I do the same thing to both sides, I'm not changing anything. So adding these natural logs in is not changing anything, and we're still good. So what does this do for us? Well, It allows us to go back to previous work we've done. And think of our end goal. It's to get this x by itself. What rule or property can I use right now? Think about it. Go back and look. It's good to do some of this on your own. So do some digging, all right? So I'm going to start it now. But I have this exponent here, and I'm dealing with logarithms. So I can use the logarithmic properties that we previously learned, and this one's called the power rule, where I could bring that x to the front. So now it's x times the natural log of 7 is equal to the natural log of 60. Now look what happens. This is great for us. Now it's x times the natural log of 7 is equal to the natural log of 60. So when I'm multiplying two things, how do I get rid of one of those things? Divide. So if I divide both sides by the natural log of 7, then I get my x by itself. These become 1, go away essentially. So x is equal to the natural log of 60 all over the natural log of 7. All right. So it's also good to note here that this is your answer, but it's also good to note that I chose the natural log up here to apply to both sides, but I could have chose log also. You will wind up with the same answer in the end. So I just choose natural log because typically that's a little shorter to write, and that's typically what we'll see later on in more examples. All right, I'm going to pause the video, start a new one, and we're going to look at some more examples.